Let us now look at the last main, which is numericals. Here, a student should answer 3 out of 7 questions. Many students fear numericals, but keep in mind that numericals is very easy to score marks because the questions are straightforward. Just learn the formula and practice few numericals and you will be good to do well examination. If some student has fear about numericals, then the best way would be to solve basic numericals, which involves simple problems like simple substitutions, and then from there gradually do little difficult problem. But the worst case, if a student doesn't know how to solve numericals, at least learn the basic formulas, because according to blueprint it has been mentioned as to where will numericals be asked. So from those chapters, only whatever has been prescribed in syllabus from blueprint point of view, in those chapters at least learn the formulas and at least write the formulas in the answer. But ideally, a student who prepares decently also should be able to answer all the numericals, because the numericals are straightforward and also there is enough choice in the question. So don't neglect numericals thinking it is difficult. It isn't. It is very straightforward. 44 says two charges of 2 microcoulomb and 8 microcoulomb are separated by 4 centimeter. Calculate the electrostatic force between them if the distance between the charges is halved. So this is second part of the question. If distance between the charges is halved and a medium of dielectric constant 2 is placed between them, find the new electrostatic force. Also find the change in force. So here there are 3 parts. First case, we need to find the force between 2 charges, the first part. Second part, if distance is changed and between the 2 charges if something else is placed, then the force will change. We need to find that force also, the second part. Third part is find the change in force. So the 3 parts here, let us do it one by one. In numericals, when it comes to physics, the question could be quite lengthy as seen here, but don't assume that lengthy means difficulty. It isn't. The statements are quite straightforward. You just need to understand the question. If somebody is not able to understand what is given here, then read the question at least once or twice or thrice till you get the question and solve from there. And also keep in mind that sometimes the quantities may not be in SI system. Make sure that every quantity is in SI system, and also make sure that the answer what you write also has a SI unit in it. So let's start the question. The first part says two charges of 2 microcoulomb and 8 microcoulomb are separated by 4 centimeter. Calculate the electrostatic force between them. So let us take 2 points. I'm drawing very big here, but these are assumed to be point charges. It's drawn very big here. The distance between them is given as 4 centimeter. So let us call this as a charge of 2 microcoulomb. Here it is 8 microcoulomb, and distance is 4 centimeter, which is 4 into 10 power minus 2 meter. So while solving the answer, the first thing would be to write the data given. So start like this. Say Q1 is equal to 2 microcoulomb, and then Q2 is equal to 8 microcoulomb, and also the distance between them, if you call as R, that R is given as 4 centimeter, which is 4 into 10 power minus 2 meter. The first part. Second part is the distance is halved, so we'll call R dash. The distance is R by 2, that will be 2 centimeter, which is 2 into 10 power minus 2 meter, and also the dielectric constant, which is called as epsilon r, or this running K, this is given as 2. So we need to find what is the new force. So in exam there is no need to draw diagram, but then drawing diagram would make it look much better, and also will have more clarity about the numerical. Always try to incorporate diagram in the answer. The first part is to find the force. So force between 2 point charges is given as 1 by 4 pi epsilon naught. It is q1 q2 by 1 by r square. That is equal to, if you call this as point A and then point B, that is equal to, it is q1 by q2, and the constant 1 by 4 pi epsilon is already given as a constant here. Learn this value also. Sometimes if they don't give it, you should know this value, which is a known constant. So putting it back here, q1 is, it is microcoulomb. Micro means 10 power minus 2. So it is 9 into 10 power 9, that is a constant, into 2 into 10 power minus 6 into 8 into 10 power minus 6 by 4 into 10 power minus 2, the whole square. Now 4 squared is 16, so you can cancel directly here, because 8 into 2 is 16, it gets cancelled. So don't look at solution here, rather you can try to solve on your own and then verify answer what has been done here. That is equal to, it is 9, the powers are, it is 10 power 9, and this is minus 12, and from the bottom it becomes plus 4. So 9 plus 4 is 13, minus 12 would be 1. So force is equal to 9 into 10 power 1, or 90 Newton. This is a force. Now since force is vector quantity, always write with direction, or at least say it is a repulsive force. So force is, it is a repulsive force. Second part says that the distance between them is halved, and between them a medium is introduced. Now in such case the force form will change. We'll write force in any medium. I'm just writing F suffix m, that is equal to, it will be q1 q2 by, it will be 4 pi epsilon medium into r square. Epsilon medium is given as epsilon r into epsilon naught. This is called as dielectric constant. So from here what we get is, we get q1 q2 by 4 pi epsilon medium becomes epsilon naught into 1 by r square, that into 1 by epsilon r. This is the formula what we write, but in this case r is changed. It is not same as r earlier, it has been changed. We call that as r dash or r1. So I'll just call this r1 here, or r dash square. So if you put it back here, you can write this as q1 q2 by 4 pi epsilon naught, and r dash was r by 12, r by 2. So it becomes r by 2 the whole square into 1 by epsilon r. If you rewrite this, then the force in the medium is equal to, in examination write one below another, don't write next to each other, there will be enough space to answer it. I'm writing here to save space in the page, otherwise keep writing steps one below another. So it will be q1 q2 by 4 pi epsilon naught. This becomes r square, 2 goes on top, so it becomes 2 square becomes 4, so 4 by epsilon r. But this was the force in air, that's the earlier case, and that answer was 90 Newton. So force in the medium is 90 into 4, by epsilon r, which is given as 2. So from here you can say 2 ones are 2 twos are. Therefore, force in presence of a medium is 90 into 2, which is 180 Newton. So this is a required force. Last part says find the change in force, that we call as delta F. Delta F is a change in force which will be F in presence of a medium minus F in free space. It was 180 minus 90, which is 90 Newton. So this is a required answer. Students should practice more numericals in this chapter because this is a very simple chapter to solve numericals. It looks quite lengthy here, but then what is involved is only coulombs, nothing beyond this. So don't look at length of the numerical and think it's difficult. Length is sometimes misleading. Just look at the steps involved. There isn't much technical concepts here. It is just basics of Coulomb's law only. We will look at next example, which is 45. So 45 says a parallel plate capacitor consists of two circular metal plates, each of radius 1.38 centimeter. A coating of Teflon, which is 40 micrometer thick, is applied to the inner surface of one plate to provide a dielectric layer, and then the plates are pressed together. Find the voltage to be applied between the plates of this capacitor to establish a charge of 5 Nc. N stands for nanocoulomb on each plate. Here some constants are given. So first and foremost, we'll draw a rough capacitor which has two plates. They're very, for example, let us think they're very far away. So if the distance between them is taken as d and the area of each plate is taken as a, and the capacitance is given as C is equal to epsilon naught A by d. Suppose between the plates, if there is some other medium present, like a dielectric medium present with dielectric constant, say epsilon r, or just as let us call it as a medium of a different, we call it epsilon m. It has different permittivity. So in such case, C in presence of a medium is equal to, the form is same, which is epsilon for the medium into A by D. But in most cases, they will not give what is the permittivity of the medium. Rather, they will give in terms of its dielectric constant. As seen in the previous numerical, dielectric constant is called as K, is defined as, it is also called as epsilon r. This is called as relative permittivity. The idea is same only here. That is given as epsilon in the medium by epsilon naught. Therefore, epsilon for a medium is equal to K into epsilon naught. Putting it back here, what we get is, we get capacitance in presence of a medium between two plates, which is Cm, is K into epsilon naught A by D. Again, write the data given. I'm not writing here, but whatever data is given, just write it once so that it becomes easy to identify the question. So this is capacitance in presence of a medium. But here what is given is a small Teflon coating is applied whose thickness is around 40 micrometer, 40 micrometer, and then the question says, after applying this Teflon coating, the plates are pressed together, which means what I get here is, we have two plates which are very close to each other. The circular plates, there is a very small gap between them. It's not shown here. It's a very small gap, and this gap is filled with a Teflon coating. It's a very small gap. Don't try to scale this because the gap looks very big here, but it's very small gap. So basically between the two plates Teflon coating is present, which means in this case D is nothing but something which separates them, and here what separates them is a Teflon coating whose thickness is given as 40 micrometer. Therefore this D is equal to 40 micrometer, which is 40 into 10 power minus 6 meter. This is what is D. So here D means distance between the two plates, and then K here is given as 2. Here K is given as 2. So we know what is K from here. We know what is D. Let us find what is A. A means area of the plates, and since these are circular plates, the area is given as pi into r square. Pi into r here is given as 1.38 centimeter. Keep in mind, it is 1.38 into 10 power minus 2 the whole square, because it is a circular plate, and for circular plate the area is given as pi r square. That is equal to, it will be 3.14 into 1.38 the whole square into 10 power minus 4. That will be equal to around 5.966 into 10 power minus 4 meter square. You all can verify and see this. The answer will not change. So putting it back here, C in presence of a medium is equal to K was 2 into epsilon naught is again a constant whose value is already given here, which is 8.854 here, 8.854 into 10 power minus 12. So it is 2 into 8.854 into 10 power minus 12, that is epsilon naught, and A is given as 5.966 into 10 power minus 4 by D. D here is a distance which is 40 into 10 power minus 6. So C in the medium is equal to, it will be 105, that is numerator will be 105.6 into 10 power minus 16 by 40 into 10 power minus 6. So C in the medium is equal to, it is 2.64 into 10 power minus 10 farad. So this is the value for capacitance in the medium, but it's not required here, because what we need is to find the voltage to be applied across the plate so that charge of 0.5 nanocoulomb is established. But for capacitor, the formula or relationship between charge and capacitance is given by charge is equal to C into V. In this case it becomes C for the medium into V. So to find V, V is equal to Q by Cm. So to find V, what we need is Cm, hence we found what is Cm from here. So we'll again do it here only. So this V is equal to Q. The charge what is present on the plates is 0.5 nanocoulomb. See, the idea here is, if you have two plates and then if we connect to a battery, then charge starts to flow, a current flows, so that this plate becomes charged positively and this plate becomes negatively charged. So charge on any one plate is 0.5 nanocoulomb. That's the meaning of Q. So Q here is charge on any one plate, which is 0.5 into 10 power minus 9, because it is nanocoulomb, by V was 2.64 into 10 power minus 10. Solve this, we get V is equal to, it will be 0.189, that is 0.5 by 2.64 is 0.189 into, it becomes 10 power minus 9 plus 10. So this goes on top, it becomes into 10, or finally V is equal to 1.89 volt. Again, write with units. If a student misses this, marks will be cut for this also. So write with units. 46 says two cells of EMF 3 volt and 4 volt and internal resistances 1 ohm and 2 ohm respectively are connected in parallel so as to send the current in the same direction through an external resistance of 5 ohm. Find the potential difference across 5 ohm resistor. So what is given is there are two cells and these cells are connected in parallel. So first let's draw the two cells, a cell like this and a cell like this, and these two are in parallel. Across this combination we have an external resistor of value 5 ohm. So if we take like this, we have an external resistor of value 5 ohm. So this is a 5 ohm resistor. Now this is a 3 volt battery with 1 ohm as internal resistance, and this is a 4 volt battery with 2 ohm internal resistance. Now we can do it in two ways. One way is to use direct formulas for parallel combination, or other is to use Kirchhoff's law, but then using the formula would be easier. So here both the batteries which in current, let us call this as current I1, this is I2. At this point let us call as point P, the current joins, let us call that as I. So current I flows through the resistor of value 5 ohm resistance, and at this point let us call as point Q, it enters. So again the current I enters, comes at point Q, it finds two branches out of which a part of it goes to I1 and a part goes to I2. So as I told, we could find using Kirchhoff's law, or more simpler way is to use equivalent resistance concept, which means we can replace these two cells by single cell, such that even that cell will send the same current. So the current sent by that cell is also I, and resistance value is 5 ohm only, where this will have an equivalent resistance called as RP, which is internal resistance, and an equivalent EMF called as EP. So basically whether you put two cells or three cells or many cells or a single cell called as equivalent cell, the effect is same. So here the formula for EP is equal to, it is E1 R2 plus E2 R1 by R1 plus R2. This is a very important question. This itself could be asked as a 5-mark derivation, and also RP is equal to R1 R2 by R1 plus R2. So these are the required formulas. If a student knows this formula, it becomes simple from here. So EP is equal to, if you call E1 as, so the first cell, so it becomes 3 into R2 is 2 plus E2 here is 4 into 1 by 1 plus 2. So from here what we get is, we get E P is equal to 6 plus 4 by 3, that is 10 by 3 volt. So the equivalent EMF here is 10 by 3 volt. Let us find its equivalent resistance also, which is given as RP. This RP is R1 into R2, which is 1 into 2 by 1 plus 2, that is 2 by 3 ohm. So here it is 2 by 3 ohm. Now we know what is current given by. I'm just doing sideways here. Current in any circuit is given by net EMF by net resistance. Net EMF here is 10 by 3 volt. Net resistance, there are two resistance now. Resistance of 5 ohm and 2 by 3 ohm. So they are in series because same current flows. So it becomes 2 by 3 plus 5. Let us find this I. We want this I because the voltage drop across the component or across the resistor is given as I into R. If you know what is I, then you can find what is the voltage drop across this. Keep in mind that the voltage drop is not 10 by 3. It would have been 10 by 3 if this was not there. But since this battery has an internal resistance, the voltage or EMF will not be same as the voltage drop here. That is equal to 10 by 3, and if we take LCM from here, it becomes 2 plus 3 into 5, which is 17. So 3 into 5 is 15 plus 2 17, 17 by 3, that is equal to 10 by 17 ampere. So current flowing is 10 by 17 ampere. Finally, the question says to find the voltage drop, which is I into R. I here is 10 by 17 and resistance is 5. Therefore, the voltage is equal to 15 by 7 volt, which is equal to 2.94 volt. So this is the required answer. 47 says two circular loops of radii 6.2 centimeter and 3.14 centimeter are arranged concentric to one another with their planes at right angles to each other. If a current of 2 ampere is passed through each of them, then calculate the magnitude of the net magnetic field at their common center. To understand this, you should know that if you have a current carrying coil and the current flows in one direction, say current is I, then the magnetic field at the center of the coil, which is given as say center O, the field here is given as mu naught I by 2 into R, where R is the circle's radius. So this is the formula to be used here. Now here we have two circular loops of different radii, but these loops are placed with their planes at right angle to each other. To understand this, if you have a current carrying loop as seen earlier, if current flows in one direction, by using right hand clasp rule, the magnetic field will be normal to the loop. This is how the field will be. So if you have two loops, their planes are normal to each other. So we can take one loop like this and one loop to be like this. So we have two loops, there are two circles, there are two loops which are normal to each other. Let us call this as say loop 1, this as loop 2. Let us assume that the current flows in anti-clockwise direction in this as well as anti-clockwise in this. So for the first case, the magnetic field for the first case will go out like this. We call it as B1 because it is normal to the plane. For second loop, the field goes like this, which is upward. We call it as B2. We have two fields. Now we need to find at the common center what is the magnetic field. So there is one field which goes out like this, which is called as B1, and one is B2. So if we redraw them, we have B1 which goes out like this and B2 which goes out like this. This will be B2. Now we need to find the net field. Now we have two vectors which are at normal to each other. So from From parallel law, the resultant vector is given as under root of a square plus b square plus 2 into a into b into cos theta. In exam, there is no need to write all this law. Just draw a basic diagram like this and tell the field will be normal to each other. If you want, you can draw this, or you can skip this also. Don't even write the formula. Just say that, directly say that the resultant field, which is called as b, that is equal to under root of, it is b1 square plus b2 square plus 2 into b1 into b2 into cos 90, and cos 90 is 0. This becomes 0. So that term goes away. Therefore, what remains is b is under root of b1 square plus b2 square. This is the formula. But you write the formula where b itself, which we wrote earlier, that b itself for any loop is given as mu naught I by 2 into radius. Let's find the first field. So b1 is equal to mu naught is already constant, which is 4 pi into 10 power minus 7. So it is 4 pi into 10 power minus 7 into current. If you call this as loop 1, the current was given as, it is 2 ampere in each case. So it is 2 by 2 into radius in the first loop is given as 6.28. So write as 6.28 and it is centimeter. So that will leave 10 to the minus 2 here. Now recall that the value of pi is 3.14, which means you can say it is pi 1s are, pi 2s are, because 2 pi would be 6.28. So that's the reason that they given the radius as multiple of pi. So it becomes easy to calculate. And then this 2 gets cancelled with 4. Therefore, we get b1 is equal to, it is 2 into 10 power minus 7 plus 2 becomes 10 power minus 5 Tesla. This is what is b1. Similarly, if you want to find what is b2, I'll do it side by side only, but in exam, keep doing it one below another. So b2 would be the same form, which is 4 pi into 10 power minus 7, that is mu naught. The formula is mu naught I by 2r, and I also is same, which is 2 ampere by 2 into radius in the second case is given as 3.14 centimeter. So that will be 3.14 into 10 power minus 2. Keep in mind that the diagram is not representing the radiuses, because here both look similar, but in exam try to draw diagram as per the radius given, or if you can't, it's fine, at least draw a basic diagram as given here. Again, pi is 3.14, so this and this gets cancelled. Therefore, what we get is, again here 2 gets cancelled. b2 is equal to 4 into 10 power minus 5 Tesla. Now let us find the resultant phase. I am doing it here only, but as I've been telling you all, in exam don't do these things. I'm just doing to explain the concept so that you see the values here only. Otherwise, do it one below another. The resultant field is under root of b1 is 2 into 10 power minus 5 the whole square, plus this is 4 into 10 power minus 5 the whole square. So it becomes 4 into 10 power minus 10, this is one term, plus 16 into 10 power minus 10. From here 10 power minus 10 is common, that comes out, that becomes 10 power minus 5, because root of 10 power minus 10 is 10 power minus 5, and what remains is, it is root of 20. Root 20 is around 4.47, because root 4 square is 16, and 5 square is 25, so the value is between 4 and 5 only. It becomes 4.47 into 10 power minus 5 Tesla. So this is the required magnetic field. If they ask direction, then you can use again the parallel law to find direction also. What it says, an object is placed at 10 cm in front of a concave mirror of radius of curvature 15 cm. Find the position and magnification of the image. So here it says find the position, which means find what is V, and find the magnification, which is M. Also write the nature of the image. In such numericals, always observe what has been asked. So an exception in ray optics is that we can write the answer in terms of centimeter only. There's no need to convert in terms of meter. That's what many books will write for ray optics. So it is fine to write in terms of centimeter only. So here it is a concave mirror, and recall that for concave mirror, how will the image look like? We have a principal axis. This would be its pole. Here the radius of curvature is 15 centimeter. It's 15 centimeter, and the focal length is given as r by 2, which is 15 by 2 centimeter, which is 7.5 centimeter. So let us mark some point here is C, which is center of curvature, and somewhere here is the focus point, which is 7.5. An object is placed at 10 centimeter. 10 centimeter means it is somewhere in between C and F, not center of it, but somewhere in between C and F. So let us place an object somewhere here. So we need to find where is the image formed and its nature as well as magnification. So we know that from mirror equation 1 by F is 1 by U plus 1 by V, or 1 by V is 1 by F minus 1 by U. But keep in mind that in case of ray optics, using sign convention is very, very important, otherwise the whole answer will go wrong. So by sign convention, U would be minus 10 centimeter, because the light is going from left to right like this. But to find U or to find R, we go like this. We go like this to find what is U or R. Similarly, even here R also is negative. So actually you should put here minus by using sign convention. I just wrote the numerical value here, but with sign convention even R also is negative. So R is equal to here minus 15 centimeter. F is equal to R by 2, which is minus 15 by 2 centimeter. This is what is the value of F. So putting it back here, 1 by V is 1 by F, which is 1 by minus of 15 by 2 minus of minus 1 by 10. Be careful while solving this simple numericals, because some students tend to make mistakes here also. Avoid it. So it will be minus 2 by 15, 2 goes on top, plus 1 by 10. Again it is from your basic LCM. So minus 20 plus 15 by 10 into 15. Again, don't copy from here. Try to solve on your own and verify answer as to what we get from here. That is equal to minus 5 by 150. This is 1 by V, or V is equal to minus 150 by 5, that is minus 30 centimeter. Minus n means that the image is formed in front of the mirror. Now distance between P to C, this distance was 15 centimeter, but the image is formed at distance of 30 centimeter. So somewhere here image is formed, and we know from properties that of concave mirror that it will be an inverted image, which is real image. So we found the first point, which is V. The position is found out. It is at this distance, and it be an inverted image, because real means it's an inverted image. The second part says find the magnification. Again, here many students get confused as to what signs to put for V and U. We just need to find magnification. Just write mod of V, mod of M. That will be V by U. It's only the magnitude, which is 30 centimeter, 30 into 10 power minus 2 by 10 into 10 power minus 2. So M becomes equal to 3. So it's enlarged. So again, don't just stop here, write in words. Say the image formed is real, inverted, and enlarged. So should complete like this. So when it comes to ray optics, whenever question says to find such parameters, always write the answer by ending with a statement. That looks much better from exam point of view. 49 is quite lengthy. The question says two narrow parallel slits separated by 0.850 millimeter are illuminated by a light of wavelength 600 nanometer, and the viewing screen is placed at 2.80 meter from the slits. Find, there are two subparts here, find the phase difference between the two interfering waves on the screen at a point 2.50 millimeter from the central bright fringe, and the ratio of intensity at this point to intensity center of the bright fringe. It looks a very lengthy question here, but the basic idea is quite simple. This is based on Young's double slit experiment, where we have a screen, we have two slits, narrow opening, and front we have a screen. Now what happens here is, if we look at center of the slits, this would be a bright band. The distance between this S1, the slit S1 to S2 is taken as small d. It is from center to center. It's a very small opening, so it's written like this, but it is from center to center. And just write a little far away, S1 and S2 are the slits, and D is the distance between center of the slits to center of slits. Now question says the distance small d, which is two narrow parallel slits separated by 0.850 millimeter. So here small d is given as 0.850 millimeter, illuminated by light of wavelength so much. So lambda is given as 600 nanometer, and view screen is placed at 2.80 meter. So distance between this to this is called as capital D, and this distance is given as 2.80 meter. First point is find the phase difference between two interfering waves on the screen at a point which is 2.50 millimeter from the central bright fringe. So somewhere here we take a point. It's drawn very far away, don't measure it. So we call this distance as some delta, for example. So this delta is given as 2.50 millimeter. Now waves from here will go to this point, and waves from here also will come to this point. Now these waves will have different path difference. So we need to find what is their path difference. So that path difference we call as delta x. That path difference is given as, it will be delta into small d by capital D. That's what the path difference formula. It's done in theory classes for all. That is equal to, this delta is given as 2.50 millimeter, which is 2.50 into 10 power minus 3 into D, which is 0.850 into 10 power minus 3 by capital D, which is given as 2.80 meter. The reason that you want this delta x, that is because the question says to find the phase difference, but phase difference is given as 2 pi by lambda into path difference. This is the form for phase difference. So we should first find what is the path difference. This is called as path difference. Path difference means the extra distance traveled by one wave. Here wave from S2 will travel extra distance, that is called as path difference. This delta x is equal to, from here it becomes equal to 0.7589 into 10 power minus 3 meter. Just verify and see, this is what the answer would be. Now phase difference is 2 pi by lambda into path difference, that is 2 into pi. Lambda was given as 600 nanometer, which is 600 into 10 power minus 9 into delta x, which is given as 0.7589 into 10 power minus 3. To solve it, this delta phi is equal to, it will be around 2.52 into pi. This is what is delta phi. Where you can see it, this is what delta phi is. That's the first part of the answer in terms of radians. Second part says, find the ratio of intensity at this point to intensity at the central bright fringe. Now at this point we may get some kind of a intensity. This could be bright or dark also, but center is always bright. Since the two waves come from same source S, the intensity of these two will be same only. That will be called I naught. And also the intensity at any point, which is called as IP, this is given by formula which is 4 I naught into cos square delta phi by 2. This is the formula for intensity. Again here it's quite lengthy problem because they're given too many of variables here. So in exams, avoid such problems if you're not sure about the answer. Rather you'll find some easy numericals to be solved. That is equal to 4 into I naught into cos square delta phi by 2. Now it becomes difficult to find what is the value of this without a scientific calculator. So in such cases, because even in the logbook what you get, it will be in terms of degree only, not radians. So in such case you need to first convert this in terms of degree. To avoid the problem, what you can do is, we can approximate here and write this as 5 by 2 into pi, because 2.52 is close to 5 by 2. So delta phi is 5 by 2. But we want in terms of degree, not radians. So recall that pi radians is equal to 180 degree, which means here it is 5 by 2 pi radians, That will be 5 by 2 into 180 degrees. So 2 ones are 2, 90s are 90 into 5 would be 225 degrees. So it becomes 225 degree. But again we want cos of this by, there's a mistake here. The mistake is, we know that pi radian is 1 degrees, but here it is delta phi by 2. Delta phi is pi by 2 into pi by 2. It becomes phi by 4 pi. So if you multiply here, so phi by pi is equal to pi by 4 into 180 degrees. Understand that pi radian is equal to 180 degrees. If you want, you can bring pi down also. Say that 1 radian is equal to 180 by pi degrees. If you want to find what is 5 pi by 4, so 5 pi by 4 again multiply by 5 pi by 4 is what we get. So it goes in 4, not 2, because 2 into, I wrote earlier as 5 by 2 into 180, that's actually 90, 45 in 90, it will be 450 degrees, but there is by 2 here. So I should done by 2, that I missed it out. Redoing it. So it will be 4 ones are 4. It will go in 45 degrees. So 5 into 45 would be 225 degrees. Basically, delta phi by 2 is so much. Now what you want is, you want cos of this value. So cos of 225 degrees, we can write this as cos of 180 plus 45 degree. Cos of 180 plus 45 lies in third quadrant. In third quadrant, cosine is negative. Since it is 180, cos remains as cos only. Therefore, this becomes equal to minus of cos 45 degree, that is minus of 1 by root 2. This is what is cos 225. So if you put it back here, then what we get is, it is cos square of this value. So just write this as, it is cos of delta phi by 2 the whole square. That is 4 I naught. Cos of delta phi by 2 was cos 225, which is minus 1 by root 2. So it is minus 1 by root 2 the whole square. That is equal to 4 I naught. Squaring minus becomes positive by 2. It becomes 2 I naught. So at the given point, the intensity is 2 times I naught. This is the intensity at this point. But question says, find the ratio of intensity at this point to the intensity center of it. At the center, if you write at center, so at center the intensity would be 4 I naught cos of, at center delta phi is 0, because if you look at this, both waves from here and here travel same distance to center. So to center, waves coming from here and here will travel same distance. So there is no phase difference, which means for center delta phi is 0. It becomes cos 0 the whole square, because it is cos square of the value, that is equal to 4 times I naught. So intensity center is 4 I naught. Now the question says, find the ratio of intensity at this point, which is IP by intensity center. So what we need to find out is, we need to find out what is intensity at a given point by I at C, which is 4 I naught by 2 I naught, that is equal to 2:1. So this is a required answer. It's quite a lengthy problem here. In exam, I don't think there are such lengthy problem. They ask you any one of this only, or else even worse, they'll ask you simple numericals only based on Young's double slit experiment. So practice those numericals. The last example, which says the half-life of radon is 3.8 days. Find its decay constant. That's the first part. Second part says calculate after how many days will 5% of the sample be left over. For example, if you take a sample of number of atoms, let us call the number of nuclei as N0 initially. Now it will decay. Now decay half-life is given as 3.8 days, which means T half is given as 3.8 days. Now what to do here is, suppose initially if we take 1000 nuclei, then after 3.8 days it becomes half of it. It will become 500 nuclei. And after 3.8 days from then on, it becomes half of it. It becomes 250. It keeps on decreasing. So N0 is the number of nuclei initially, and N is the number at some point of time. So question says first find decay constant. That's the first part. Second part says calculate after how many days will 5% remain. So it will keep on decreasing. So we should find after how many days will 5% remain. And here what you can do is, we can write a formula between N and N0. So N is equal to N0 into e power minus lambda into T. I'll do this very quickly because it has become a very lengthy video. So we should find what is the time. But for that we should know what is lambda first. Lambda is called as decay constant. So there is a formula connecting decay constant with half-life, and that formula is T half is equal to 0.693 by lambda, or lambda is equal to 0.693 by T half. But T half is in terms of days, but the SI unit is in terms of seconds. So convert it, it becomes 3.8. 1 day has 24 hours and 1 hour has 3600 seconds. So we just write it here. This is equal to, it will be 0.211 into 10 power minus 5 per second, because it is by second, or we write lambda as 2.11 into 10 power minus 6 per second is what is lambda. Next, coming back to this question, we should find after how many days 5% remains, which means N is equal to 5% of N. That's the meaning of it. Only 5% remains, because here N is the number of nuclei remaining. Here 5% remains, which means N is equal to 5 by 100 of N0. We'll put in this formula here. Then what we get from here is that 5 by 100 into N0 is N0 into e power minus lambda into T. From here N0 gets cancelled, and also from here we can cross multiply. If you bring this down, then 1 by e power minus lambda T would be 100 by 5. If we take on top, it becomes plus, it's theory of indices. So e power lambda T is equal to 20. Now we need to solve it using logarithm, and always use natural logarithm. It will be given examination hall. Just ask the natural logarithm. Then what you can do from here is, you can write this as lambda T is equal to log of e to 20. This is natural logarithm. But if you go to natural logarithm place, you find what is the value of log 20, and if you solve it, then we get lambda into T. this log of 20 to base e is equal to 2.996, or the time we want to find out, it is 2.996 by lambda. Lambda is already found out as 2.11 into 10 power minus 6. So this is equal to 1.42 into 10 power 6 seconds. This is what is the time. In case if in exam hall, if you don't get natural logarithm, then you can convert this by using log to base 10, and that is log of 20 to base e would be nothing but it will be 2.303 log of 20 to base 10. So you find what is log 20 to the base 10 column and then multiply into 2.303. It is not complete here. The answer is done. The last step pending, which is to find in terms of days, because question says calculate after how many days. So this I leave as exercise to find, just convert this time in terms of days. That's the answer. So the entire series is completed. So here it took a lot of time to do it because I explained a lot of concepts, and also we are solving for 140 marks. The maximum max what you can get is 70 marks. So you should score 70 marks in 3 hours. But here I've explained more than 140 marks because I put some extra questions also. That's why it became lengthier. Otherwise, you could have cut it down also. Again, practice this once or twice, revise them once or twice. And also, if possible, I'll do one more model paper if time permits. So these two should be sufficient to score well in examination. So keep in mind that if you haven't prepared, it's fine. At least the minimum what a student should do is to solve this model paper and then solve at least the previous year model papers or previous year questions. So solve the previous year questions. I'm saying for students who haven't done any preparation, or somebody who's already prepared completely, those students should ideally revise. So those are well prepared, revise all the important concepts and solve this model paper as a test. You should see it as a test to solve it. For those who haven't done much preparation, with less time pending, you can't do the syllabus completely. Those students should solve the model paper and at least solve 1 or 2 years of previous question paper. In case you don't get access to previous question paper, then solve at least the pre-board papers. At least solve 2 to 3 of full papers. With this, a student can at least score more than 30 marks. That's guaranteed, provided student works harder. All the best.